Today's topic is fractions to decimals, and the date is 11/20. All right, so we have done percents to fractions, fractions to percent, decimals to percent, percent to decimals. Now we're going to do fractions to decimals. All right, so I need to know what the percent, I'm going to kind of work backwards here. We're going to fill in this whole table, and I'm going to give you a little hint on how you can do this. 0.14 is what percent, Isha? 14%. Okay, Isha, what is that as a fraction out of 100?
14 to 7/50.
Good. It reduces to 7/50. Okay, I'm going to tie this all in at the end. Okay, who wants to do 0.45? Brian.
Okay. 0.45 is 45%.
Good.
And it would be 45% over 100.
Okay.
You would simplify that, divide the each by 5, you get 9 over 20.
Okay. Good. 0.05. Maya.
5%,
Good.
and then 5 over 100, and then you can simplify 120.
Yeah, that doesn't look very good. 120. Good. All right, next, Malik.
0.9 is 90%,
Good.
and then it would be 90/100th.
Good.
You would simplify that to 45/50th, and you simplify it to 9/10.
9/10. Very good. 0.004. Christian.
Okay, that's wait, may I see the fraction first?
Sure.
Okay, it starts out as 4/1000, and you can divide it by 10, which would be 0.4%.
0.4%. So you said 4 over 1,000. Okay, good. And how can we reduce that?
You can reduce that and make it 4 over 120.
Good. Okay, so there's that fraction again. Remember, this is 2/5 of 1%. It's a very small amount. Okay, and 1, the whole number. Lily. It's not 1%, it's a whole number. What's the whole? Clayton.
100%.
It's going to be 100%. So, and that would be 1 over 1. Okay, now, back to today's topic, we're going from fractions to decimals. So that was all fine and good and fun. But let me tell you why I showed you this. Okay, it's because you can work backwards. You can take any fraction, any of these fractions, and get it to have a base of 10, 100, or 1,000, or etc. Okay, and if I expand 7/50ths and make it into 1400ths, and I read that out loud, 1400ths, oh, then I can work backwards and say, oh, that's also 1400ths. Does that make sense? So I can take a fraction, expand it back to have a base of 10, 100, or 1,000, like 4,500ths, and I can think, oh, read it out loud, this is also 4,500ths. So this is a way you could do it without doing math. Now it wouldn't look like this, it would kind of look the other way. You would say, oh, 7/50ths equals 14 over 100 equals 0.14. You were asked to change 7/50ths into a decimal number. Okay? That's kind of strange. Okay, well, you get the idea. So, A over B is a fraction, but A over B can also be considered a what kind of problem? We've been talking about this in algebra. What kind of problem, Richard? It's a division problem. Okay? Where we would do A divided by B. This idea can be used to turn any fraction into its decimal equivalent. So we just had a question, what if it's not a number that goes into 10, 100, or 1,000? Okay, well then you might have to use a decimal equivalent. For instance, let's use 3/4 as an example. Right, 3/4 is gonna be 3 divided by 4. Numerator divided by denominator. So I would do long division. Right, and you know how to do the long division here. Right?
No.
So my answer is 0.75 when I divide it. This would be my answer. Okay, 5 times 4 is 20. We have no remainder. Okay, good. Now, let's look at 1/3. Who can convert 1/3 into the division problem that we would need to do? Akash?
So you do 1 divided by 3?
1 divided by 3. We should probably just go ahead and add 3 zeros. Okay, pretty much we're going to go out to 3 spaces and we'll either know it's repeating or it stops. Okay, so 3 does not go into 1. All right, why don't you guys divide that real fast?
1 by 3, and
So what did you get?
I got 0.333.
It's going to keep going. Okay, so here's how we're going to show this. We're going to have 0 point. We're going to simplify it down to 1/3, just the part that's repeating. Just 1/3, and then you're going to put a bar on top showing that it's repeating. Okay. Now, you and your table mate, do 1/6. Go. Who has an answer for me? Hannah.
0.16.
Okay, so we know this is going to keep going. So our final answer is 0.16. I like how she dropped off the other 6's. She just gave me 1, and the 6 is repeating. Now, let me give you some vocabulary. The little bar that you see here is called a vinculum. The bar is called a vinculum. It indicates that we have a repeating decimal. The part that's actually repeating is called the repetent. Repetent. So the 3 here is the part that's repeating. The 6 here is the part that's repeating. So the 6 is the repetent and 0.16 repeating. The reason why I point that out is because sometimes you might have 0.8125, 8125. So the repetent would be 8125, the whole thing. And then you put the vinculum over just the repetent and you drop the rest. Okay, top of it. Okay, so the repetent is the part that repeats. Richard.